Hi everyone, today we're going to discuss the second half of 4.2 measure of spread notes. This is day 2, and we're going to start off with empirical rule. Empirical rule is to describe data that are bell-shaped. We talk about different kind of shapes, skewed to the right, skewed to the left, and this is a bell shape, and it's somewhat symmetrical but doesn't have to be exact. And bell-shaped curve look like this. Okay, so first thing, to summarize data, we use both graphical, numerical summaries. If the histogram for a set of quantitative, which is numbers, data is roughly bell-shaped, then the mean and the standard deviation are the typical numerical summaries that are used. A measure of center always needs a corresponding measure of variation to tell more complete story about the data set. The reason for that is, remember, we have 50% and we can have everybody the same, or one of them is too extreme of each other, but when they balance off, they are 50%. So one could be 0, one could be 100, and I still get 50. But two graphs is very different from before you answer the question. So here's the empirical rule. Empirical rule will be used often in the inferential chapter. Definition of empirical rules: you have to memorize those numbers. If a data set has a histogram that is approximately bell-shaped, then 1. Approximately 68%, you gotta know that number, 68% of the value will fall within first standard deviation. Approximately 95% of value will fall within 2 standard deviation. Approximately 99.7% of the value will fall 3 standard deviation of their mean. So what does that mean and what does that look like? How are we going to apply empirical rule onto a bell curve? Here's how you do it. First of all, you are going to draw a bell curve, and you are going to label, because I told you guys that this involves mean, which is right here, right in the middle, because mean is 50%, right in the middle. And then what you're going to do is you're going to section off. You have the first thing, which is 68%. And that 68% is going to be split for your mean, split because of your mean. So 68 divided by 2 is going to be 34 on one side and 34 on the other side. And then that will make up your 68% right here. That will make up your 68%. Then what you're going to have is you're going to have another standard deviation, and that is going to be second standard deviation, and that is going to be 95%. And that 95% split in 2 is going to be 47.5 on each side of the mean. And then if you take the 47.5, subtract the 34 you already have, that is going to give you 13.5 on each side. Then after that, you should understand when you go from end to end, from here to here, that's going to give you the 95%. Okay? Then what you're going to do is you're going to have the third standard deviation, or the 99.7. So now 99.7 is going to be another standard deviation right here. And that is going to be 99.7 divided by 2. And that's going to be 49.85 each side. And then you have to take the 49.85 minus 34 minus 13.5, and that will give you the rest of it, which is going to be 2.35 on each side. Then after that, that should give you the whole thing right here. That's going to be 99.7%. Okay? Then the last, we still have stuff left, because guess what? That's only 99.7. I still have 0.3. And that 0.3 is going to get stuck out here. That's 0.15, because 0.3 divided by 2 is 0.15, 15%. And that is going to be the rest of your percentage. And because the 0.15 is such a small percentage, that means there's going to be data there, but that is such a small amount. So most of the time, your outlier is going to be laid out there. Okay? And the outlier in this case is just the data that is not the normal data, because the normal data is stand within the 3 standard deviation, and that covers about 99.7. All right, now we understand the percentage. So now we are going to talk about how do you get those numbers. And those numbers does not change. Those percentage, those A percentage does not change. But the number does, because guess what? Every single set of data will have a different mean. Every single set of data will probably have a different standard deviation. So to start off, how do you find the number for the first standard deviation? What you have to do is you just have to take your mean plus one set of standard deviation for the first standard deviation, and then you take your mean minus the standard deviation, plus standard deviation is to the right, minus standard deviation to the left. Then the second one is going to be the mean plus 2 standard deviation to the right. What do you guys think the other side? Well, that's going to be the mean minus 2 standard deviation. And how about the third one? Well, to the right is going to be mean plus 3 standard deviation. And to the other side is going to be the mean minus 3 standard deviation. And that's all you have to do is to find the number. And then for your information, you guys already know from the calculator how to find the mean by entering the data into a list. And you also need know how to find the standard deviation. They either will be giving you those 2 pieces of information, or you can use the list function from your calculator and calculate your standard deviation and your mean. One thing I also want to add is I want to make sure that you guys understand this is the mean. Okay. S are equal to standard deviation. Okay. Few more things I want to recap. For any set of bell-shaped data, the above 8%, and they are the basic of 0.15, they are 2.35, and 13.5%, and 34%, and the other side 34%, 13.5%, and 2.35%, and 0.15. Those percentage will never change on an empirical rule, bell-shaped curve. It's the mean, which is the data you collected, will change. Also, the standard deviation will change, but you will always follow the rules. First, standard deviation will give you the 68% of the data false. Then the second deviation, the 95% of the data will fall. And the third deviation, which is 99.7% of data, will fall. But the mean and the standard deviation are the numbers that's going to change. So in this case, it never change. Only the number on the axis changes depends on the mean and the standard deviation for a particular set of data. Another thing, not everyone is average. When we hear an average salary, an average score, an average weight, etc., we need to keep in mind that the average alone does not tell us where an individual measurement falls. That's why empirical rule give us a way to create an interval, a range, where a certain percentage of individual measurements must fall. So after understand all those vocab and trying to figure out, let's apply to a real life situation. So for example 6, the mean and the standard deviation in months for the age when a child start walking are about, typo, sorry, that should be A, about 15 months and 3 months respectively. Assume the data are bell-shaped. So we have three pieces of very important information. The mean, they give it to you already. The standard deviation, 3 months. And one more important thing, the data are bell-shaped. All the things we need to construct our empirical rule, bell-shaped curve, is all there. Let's go back and use our symbols. Mean is X bar. Standard deviation is your S. For question letter A, what variables are type of variable was data collected for? Variable is number of months needed when a child starts walking. Type of variable is a quantitative because how many months? It's continuous because it could be down to the minute, the second, and all those kind of things. So that's continuous. B, what shape is the distribution of ages when a child starts walking? Well, in the question, it tells you assume the data is bell-shaped. So that should be bell-shaped. And remember, if you are using empirical data, it has to be bell-shaped, or empirical data cannot be applied because you have to have a symmetrical, almost symmetrical on both sides. That's why you can divide your 68 to 2 equal parts, your 95, and yes, and the next one is 99.7%. So you can split them up in half. So you have to have a bell shape. All right, next one. Fill the number line below with a percentage of for each of the 8 bins and 7 numbers on the horizontal axis with a number specific to this problem. So, drawing a bell shape. Still not very good. Okay, so in this case, the average is in the middle. All right, and they say the very important question before. The mean and standard deviation in the months of age when a child starts walking are about right here, 15 months. That is ding, 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 the mean. So if that is the mean, we need to label it right here. This is X bar, and that is 15. I want to put the X bar. Okay, that's X bar right here, and that is going to be 15. 15 right here. Okay, what we're going to do is we are going to label. This is 34%, and this side is 34%. And remember, this is mean plus standard deviation. And if you look at the problem, it tells you respectively. That's 3 months, and that's the standard deviation. Okay, so 3 months and 15 months, you just take 15 plus 3, so 18. And on the other side, that's a mean, which is X bar, minus 3. So that's going to be 15 minus 3, 12. Now you say, Ms. Wiesman, do I really have to write down the number? You don't have to write down those numbers. But you have to be able to tell me that's 18, that's 12, and going down, marking at the next number set is 13.5%, and that's going to be 15 plus 3 standard deviation plus another 3 standard deviation, which is 15 plus 6. And 15 plus 6, that's going to give you 21. And then if you do 12 minus 3, that's going to be 12 minus 3. Oh, 9. That's the next standard deviation location for the second one, second standard deviation. And you got to tell me that's 13.5%. Remember, we talk about those percentage does not change. Is the mean. Whatever we are comparing, things are going to change. And the standard deviation. That's why it's so important you know how to use that on the calculator, because you are not going to be able to crank it out yourself all the time. All right. The next set is going to be 21 plus 3 more. That's going to be 24. And then that's going to be 9 minus 3 more. That's going to be 6. And the percentage over there is going to be 2.35%. And down here is going to be 2.35%. And when you do that, we are left with, that's the 6th number. And the last number that we are going to put down is going to be the 0.15% and the 0.15%. And that is your standard deviation used in empirical rule. Just the mean, adding, subtracting how many standard deviation you have. Okay, now let's ask questions. What percentage of children start walking between 12 and 21 months of age? Okay, so now it's so important to figure out how to do your empirical rule, because now the question based on 12 months, well, here's 12. And 21 months. Okay, 12 and 21 months right here. What percentage of children start walking between those months? Well, look at the percentage. That's why the percentage is important. You have 34% plus 34% plus 13.5%, and all together is going to give you about 81.5% of a baby walks between 12 to 21 months of age. And then if you want to, that's the percent right there. And the next question, what percent of children start walking after 21 months? Let me erase that bar. After 12 months. Okay, let's take a look. After 12 months is going to be right here. After 12 months. Because when you are born, you start with 6 months. And after 12 months, well, after 12 months, it's going to be 2.35% plus 0.15%. And that is going to be equal to 2.5% of the children start walking after 21 months old. So if they ask you to explain this, you are going to explain 2.5% of children start walking after 21 months of age. Hope that makes sense. Example number 7. An alternative rock radio station, the lengths in seconds of 149 songs played Friday, April 18th, 2014, are described by the histogram and the information in the figure below. If a song was played multiple times, its length was concluded in the data set just once. Okay, so what I'm going to do is, it's kind of hard for you to figure out the standard deviation because you don't know the length and everything else. So I'm going to give you the information right here. The length. There's 149 songs. The mean of all the songs together is going to be 232.926. And the standard deviation is going to be 49.63. The median is 231. The minimum is 110. The maximum is 449. Okay, so now what variable and types of variable was data collected for? I would say length of the songs. And the type of variable is going to be quantitative and continuous. Then explain why the empirical rule can be applied. Now this is the time, this is B, you need to look at the histogram. Well, the histogram is kind of like a bell curve. So that's why we can apply the empirical rule, because the graph or histogram looks like a bell shape. Okay, next one. Apply the empirical rule. Okay, we're going to apply the empirical rule. So, draw your bar. Okay. Draw your curve. Middle. And let's go pick out the data from the pot above. Okay, so we know the mean is going to be 22. Oh, 230. Okay, now first standard deviation is going to be right here and right here. Label 34%, and this is 34%. And the first standard deviation, they told you add 49.63 to 232.926, and that will be your first set of deviation. So that is going to be 282.5, and the other side is going to be 132. Oh, I'm sorry, 182 and 183.2. And that's within the first interval of 68%. Then we're going to mark off for the next one, which is going to be the 85%. And that is going to be added with 13.5. So with the second standard deviation, you have 133.7, the standard deviation, which is 49.63, to 183.2 to get, oh, I'm sorry, to subtract from 183.2, you get 133.7. Over on the right hand side, you have 282.5 added to 49.63 and give you 332. And that will be your 13.5%, which is a 95 percentile. So that's 13.5%. And that's 13.5%. And going on to the third deviation, the third deviation is going to be marked, but with subtraction and addition on each side again. So this is going to be 2.35 and that's 133 minus the 49.63, and that's going to give you 84.8. 307. And on the other side, we are going to take 332.1 plus 49.63. And that's going to be 381.73. Okay, and that is going to give you the other 2.35%. Then you have the last thing that you need to add in, because they are the possibility of outlier, and the outlier will be in the area of 0.15%. And the reason outlier is, again, is the very, very unusual data that maybe a song that goes for 10 minutes, which is not going to be normal. Okay. So now the first pink one is going to be your 68%. The green set is going to give you, and the red set together is going to give you the 95%. The purple, the green, the red all together is going to give you the 99.7%. Okay, so now after we are done with that, oh, don't forget, this is also a mean or X bar right here. Okay, and that's the mean. So let's answer the question. Estimate the number of songs that have length between 133.7 and 332. So if you do that, you will see that 137 and between them. So it's this way, 133.7 and 332. So what you're going to do is you are going to add them, add all the percentage number of songs. So in this case, number of songs is going to be done this way. So you have 13.5% plus 34% plus 34% plus 13.5%. And when you add them all together, that's going to be about 95%. Because if you remember, that's actually 95% of all the songs available. Now, how many songs are we talking about? We have 149 songs. That's your N, 149 songs. That's not the length of the song. That's how many songs they play. 149 songs. So therefore, you're going to take your 0.95, because that's 95%, times 149. That will give you how many songs are within those seconds. So 0.95 times 149, and that's going to be 141.55 songs. So round it up to 142 songs. Make sure you have units, because if you put down seconds, it will be wrong. Next question. E. What percentage of songs have length less than 183.3 seconds or greater than 282.5 seconds? So in this case, let's mark it off. 183 from here to here, and or greater than 282 from here to here. Now, the easiest way is just take 100% minus 34% and minus 34%. Now, if you like being a plus person, you can take 0.15% plus 2.35% plus 13.5% and times 2, or just add them all together. But I like the easy way out. So I'm going to take 100%, which is the whole empirical rule bell curve, minus the 2 percentage I don't need, which is 34% and 34%. And which is, if you want to, that's 100 minus 68%. So 100 minus 68% gives you 32%. So in this case, you can say 32% of the songs have lengths less than 183.3 seconds or greater than 282.5 seconds. Okay, so that is how you answer the question. All right, next one. F. What percentage of songs have length greater than 282.5 seconds? So let's take a look. Erase my orange marks. 282. What percentage of songs have length greater than 282? So 282 is right here. That means longer songs. So that's going to be 13.5 plus 2.35% plus 0.15%. And that's going to be 16%. So double check. 13.5 plus 2.35 plus 15.15. 16%. So the answer should be written 16% of the songs have length over 282.5 seconds. And that's the kind of question. Now, for letter D, to be more precise, 142 songs is okay, but I probably expected a little bit longer answer. For example, 140 songs have the length between 133.7 seconds and 332.1 seconds. So if you want to actually please write that down. 142 songs have length that's how a problem is answered. Variance is just the square of the standard deviation. Some of the symbols and meanings, names, definition is right here that I expect you to understand. Mean, median, range, standard deviation, variance. So those are the definition. Please copy them down. And that will be concluding of day 2, our 4.2 measure of spread.